And this problem says that a large study of returning veterans showed that approximately 55% of the soldiers suffered from PTSD. We have 55% here, and then a random sample of 20 veterans was selected. We first want to explain why this is a binomial experiment. Our 4 criteria are: we need a fixed number of trials. In this case, the number of trials is going to be 20. We need 2 disjoint outcomes, and the outcomes are going to be either the soldier has PTSD or they don't. The outcomes have to be independent of one another, so whether one soldier has PTSD or doesn't shouldn't impact whether the next one does. And throughout the experiment, the probabilities can't change. We're going to assume a 55% probability of a soldier suffering from PTSD, so we're going to say that the probabilities don't change throughout the experiment. We're going to find the probability that exactly 10 of these veterans in the sample suffered from PTSD. Now, remember from the previous discussion that n equals 20, we have 20 trials. We're interested in this number 10, that is going to be our x value. Our probability of a soldier having PTSD is going to be 0.55, and that makes our q value, the probability of the soldier not having PTSD. You could do 1 minus 0.55, or you could just say 0.45. This is what your formula looks like. Hopefully that's going to be on your note sheet for the test. And if we plug in our n, our x, our p, and our q into this formula, this is what we get. Our power on q is n minus x, and 20 minus 10 in this case is also 10. So I'm putting this 10 here as well. Well, we need to plug this into our calculator, so here's how we're going to do it. I'm going to start with the 20. I'm going to go to Math, Probability. I'm going to choose the combination option. And we're going to do 20, choose 10. Then we're going to multiply by 0.55. That is going to be raised to the 10th power. And then we're also going to multiply by 0.45, which also happens to be raised to the 10th power. Plugging all of that into our calculator is giving us a 0.159, so about a 16% probability that out of these 20 selected veterans, 10 of them are suffering from PTSD. So that answers that question. The next question is asking us about the probability that at least one veteran suffers from PTSD. We need to remember that the probability of at least one event happening is 1 minus the probability of no events happening. And our formula for the probability of none is going to look like P of 0. What that means is we're interested in looking at the probability that out of these 20, none of those veterans suffered from PTSD. That's an x equals 0. We still have an n of 20. We still have the same p values and q values. If we plug all that into this formula, I'm getting this right here. Again, I'm plugging these numbers into this formula up here. Again, if we break out our calculator, there's more than one way to do this, but I will just type in the full equation into my calculator, which looks like this line right here. I'll hit enter, and that is a very low probability. Again, this means we're going to take this number here, and we're going to move the decimal place to the left 7 spaces. That's going to give us 6 zeros before we get our first 1. So what that means for our problem over here is that essentially the probability of none of these veterans having PTSD is basically 0. Meaning that to answer this question, the probability that at least one veteran is suffering from PTSD is essentially 100%, or 1. We can go to the next problem where we're asked what is the probability that exactly 8 veterans are suffering. And I think that we should probably use the function on our calculator that makes this a little bit faster. That involves using our distribution function. That would be second vars. And if we arrow all the way down to option A, or I'm sorry, I guess on my calculator it's option 0. The binomial probability distribution function is the one that we want. In my old school calculator, they just give me this line here. We're going to enter n, which is still 20. We're going to enter the probability p, which was 0.55, and we're going to enter the exact number that we're looking for. That's x equals 8 in this case. Hit enter, and this is giving us about a 7.3% chance that exactly 8 of our veterans have PTSD. Okay, so that answers that question. The next question is find the probability that at most 6 of the veterans in the sample suffer from PTSD. Well, this might take us a minute, but we can use our calculator. This at most 6 thing means that we want the probability of 0 plus the probability of 1 plus all of the probabilities up to 6 veterans in the sample. And essentially what we have to do to calculate all these probabilities is just keep typing in this binomial probability distribution function with a different x value. So we can replace this 8 with 0, 1, 2, 3, all the way through 6, add all of those numbers that we get up, and we'll get ourselves an answer. We did this in class, but what I mentioned was that the easy way to do this is to go back to your memory by hitting second entry until it brings up the function that you want. So I had to hit second entry a couple times there, but this binomial probability distribution function is what we want. We want to plug 0 in for x to get a number. Then I'm going to click second entry again. I'm going to replace x with a 1 to get a number, and I'm going to keep doing that until I get to 6, and I'm going to record all of these numbers. Essentially, our first three numbers have been 0. This number is 0.0002. We should start getting some non-zero values here soon. Replacing x with 5 is going to give us 0.005, and replacing x with 6 gives us 0.015. Now adding all these numbers up and rounding is basically just going to give us 0.021. That means that there is approximately a 2% chance that out of these 20 veterans, at most 6 of the veterans are suffering from PTSD. We can do the same thing with more than 15. Basically, we're adding up the probability of 16 plus the probability of 17 all the way up to 20, and we're going to do the exact same thing in our calculator. We're going to replace our x value with 16 and 17 and 18 all the way up to 20, and then we're going to add all those numbers together. And finally, in this review, we are going to find the mean, the variance, and the standard deviation of this binomial distribution. Now, the formulas for this are actually very simple. The mean of a binomial distribution is given by n times p. Those are the same n's and the same p's that we've been using in all these problems. I'm getting 11. That can also be thought of as an expected value. Out of these 20 veterans who were surveyed, we would expect 11 of them to be suffering from PTSD. As far as variance is concerned, that formula is pretty simple too. It's just n times p times q. If we multiply those three numbers together, we get 4.95, and that is our variance. As far as our standard deviation goes, as always, we can take a square root of our variance, and that is giving me 2.22 approximately for our standard deviation. So these formulas here should probably go on your note card as well. Note that these only work for binomial distributions. Okay, I think that's the longest video I've ever made. I'm going to try to edit it down as far as I can. I hope it helps you out, and I hope to see you all soon.